Hello everyone. In this session, we will discuss polynomials factor theorem. Let's see what factor theorem says. If p of x is a polynomial of degree n greater than or equal to 1 and a is any real number, that is p of x is divided by x minus a, then we can say that x minus a is a factor of p of x if p of a is equals to 0. That means in place of x, once we substitute a, if the polynomial value is becoming 0, then we can say that x minus a is a factor for the given polynomial p of x. Or in other words, if p of a is equals to 0, if x minus a is a factor of p of x. So according to factor theorem, x minus a, we can say it as a factor for the given polynomial if the polynomial value becomes 0 when we replace x with divisor value. Let us understand this factor theorem statement by considering simple examples. Question number 1. Examine whether x plus 1 is a factor of x cube plus x square plus x plus 1. So in order to find out given binomial is a factor or not, let us find out the polynomial value. Let us first equate x plus 1 to 0. So which implies x is equals to minus 1. Now let given polynomial be p of x, that is equals to x cube plus x square plus x plus 1. Now we'll calculate p of minus 1. So which is minus 1 cube plus minus 1 square plus minus 1 plus 1. So this will be minus 1 cube is minus 1. This is plus 1. Here minus 1 and plus 1. So here we can cancel out minus 1 plus 1, minus 1 and plus 1. So that is equals to 0. Therefore, p of minus 1 is equals to 0. According to factor theorem statement, we can say that x plus 1 is a factor for the given polynomial. Right? Let's move on to next question. In question 2, find the value of k if x minus 1 is a factor of p of x. So here it's given that x minus 1 is a factor and we have to find out k value. Let us write first p of x, that is 2x square plus kx plus root 2. And it's given x minus 1 is a factor. That means x minus 1 is equals to 0, which implies x is equals to 1. Now it's given that x minus 1 is a factor. That means p of 1 is equals to 0. So let us substitute in p of x in place of x 1. So it will be 2 into 1 square plus k into 1 plus root 2 is equals to 0, which implies 2 plus root 2 plus k is equals to 0. Therefore, k is equals to minus 2 minus root 2. So, as it is given x minus 1 is a factor, we are finding out k value by equating polynomial value to 0. Right? By using factor theorem, we can factorize a quadratic or a cubic polynomial. Let us look into factorization of a quadratic polynomial. Factorize 6x square plus 5x minus 6. Let us factorize this by using splitting the middle term, which you have discussed in your lower grades. So that is 6x square plus 5x minus 6. So in order to split the middle term, we have to consider the product of last two terms, that is 6 into 6. So it is 36. So we have to find out the factors for 36 such that once we add or subtract, we should get 5. That is the middle term. So we'll consider factors as 9 and 4. So that 9 minus 4 is 5. Right? So let us write 6x square. Next comes the question, which one should be negative and which one should be positive. If you observe here, 5 is positive. That means the greater number sign should be plus. So we'll write it as 9x minus 4x minus 6 is equals to 0. So here we'll consider 3x as common factor. So it will be 2x plus 3. Here once we take minus 2 as common, so it will be 2x plus 3. So that minus 2 into 2x, it is minus 4x, minus 2 into 3, it is minus 6. Therefore the factors are 3x minus 2 and 2x plus 3. So these two are factors for the given equation, right? Let us solve question number 4, which is a cubic polynomial. Factorize x cube minus 2x square minus x plus. Let us find out first one factor by using trial and error method. So let us try with x minus 1 is equals to 0, which implies x is equals to 1, right? So let us substitute p of 1. So it will be 1 cube minus 2 into 1 square minus 1 plus 2. So this will be 1 minus 2 minus 1 plus 2. So here minus 2 plus 2 minus 1 and plus 1. So it is becoming 0. Therefore we can say that x minus 1 is a factor. Now once we know x minus 1 is a factor, let us use division method in order to find out other factors. So the given dividend x cube minus 2x square minus x plus 2. As we know that in division method, first we have to consider the first term in the dividend and first term in the divisor. So it will be x cube by x, which results x square. So x square into x, it is x cube minus 1 into x square, it is minus x square. On subtraction, minus and plus, so these two will cancel out. Minus 2x square plus x square, so it is minus x square, bringing minus x down. Now it is minus x square by x, which is minus x. So minus x into x, it is minus x square, minus into plus, minus x. So this is plus and this is minus. Here we can cancel out these two. So it will be minus 2x plus 2. On dividing minus 2x with x, we'll get it as minus 2. So minus 2 into x, it's minus 2x, minus into minus plus 2. On subtraction, these two will cancel out. So the quotient q of x is equals to x square minus x minus 2, which is a quadratic equation. So let us factorize this by splitting the middle term. So it will be x square minus 2x plus x minus 2. So once we take x as common, it will be x minus 2 and plus 1 into x minus 2. Therefore, it will be x minus 2 into x plus 1. Therefore, factors for the given polynomial are x minus 1, x plus 1 and x minus 2, right? In next session, we'll discuss algebraic identities. Please subscribe to our channel for latest updates. Thank you for listening and have a nice day.